Welcome to the Mining and Metallurgical Society of America webinar series. MMSA is an association of senior industry professionals who conduct themselves and their work to the highest standards. The society only accepts applicants who have been educated, trained, and experienced in the mining industry for at least 10 years and who have been referenced by colleagues and industry peers. Once a member, a professional may apply to be a qualified person with the earned expertise in one or more defined professions from specific and extended work in the industry. If you are interested in becoming an MMSA member, please be sure to check out our website at mmsa.net for information on the application process. The Society is dedicated to increasing public awareness and understanding about mining and why mined materials are essential to modern society and human well-being. The Society concerns itself with fundamental principles and with problems facing the industry in such areas as legislation, economics and education, as well as environmental concerns, labor relations, and health and safety. Representatives of the Society from time to time testify before legislative bodies and provide advice to federal agencies. The MMSA provides continuous professional development opportunities for its members through the QP webinar series. The series provides subject matter expert lectures on a wide range of mining topics and is presented most months of the year. I am Kristen Guerin-Davy, MMSA member and social media and webinar director. I'll be introducing today's webinar. The title of today's webinar is Mining Construction Disputes, Claims, and Mitigations by Corey Milburn of Delta Consulting Group and Matthew Nichols of Delta Consulting Group as well. Questions can be entered in the chat. The speaker will answer the questions after the presentation is completed. Please turn off your camera unless you are asking a question, and I'll hand it over to Curtis.
Thank you, Kristen, and good afternoon, everyone. Thank you for joining us today. I have the pleasure of introducing Mr. Milburn and Mr. Nichols. Corey Milburn is certified as a forensic claims consultant, a planning and scheduling professional, and a cost professional. His career focus has been resolving claims arising from construction project delays using a basket of analytic tools, training, and 25 years of experience. Corey holds an MBA, a Bachelor of Science in Business Administration, and was trained in the U.S. Army Special Forces. Matthew Nichols is a certified planning and scheduling professional who has spent his career to date evaluating construction schedules and analyzing construction claims of delay, loss, and damages. His project experience spans 4 continents at civil, mining, nuclear, oil and gas, and environmental projects, and includes advisory services, project analysis, and expert witness testimony. He is a civil engineer and holds a master's in construction engineering and management. In light of recent and continuing cost blowouts and litigation in the mining construction or construction of mines sector, we are very pleased to have these gentlemen here today, and we eagerly welcome your commentary. Over to you, Corey and Matthew.
Thank you.
Good. Thank you all for the introduction, and it's a pleasure for Matt and I here to present today. When we were initially approached by MMSA to talk about this subject, just as Curtis discussed, these construction claims can be highly disruptive to projects, both in terms of the financial issues as well as stress on the relationships between the contracting parties. So the whole point of this discussion today is understanding what are construction claims, why do they occur, and what are some of the unique aspects of mining projects that often materialize or may result in construction claims, and then most importantly, how to avoid them. And just foreshadowing, most often we see that construction claims, whether it be mining or other another industry, it's a breakdown in communications and understanding. So hopefully today, after going through some of this, you'll be a little bit better off and know a little bit more about construction claims. So Delta Consulting Group, we've got offices throughout the U.S., Canada, the United Kingdom, as well as in Spain. We do work throughout the world. In addition to the construction side, we provide project advisory on construction projects, as well as we have a forensics accounting group and the insurance and recovery group that deals with the builder's risk side. Curtis did a great job of going through my background. I grew up on construction sites. I worked for the first 50% of my career out in the field initially as a laborer, working my way up through project controls, project management, and then went into construction consulting. In that time frame, I managed to fit in about 5 years in the U.S. Army, where I served as in the U.S. Army's Special Forces, or what's commonly referred to as Green Berets, in support of what was called at the time the Global War on Terrorism. Certified forensic claims consultant, planning, scheduling professional, and cost professional. I'll hand it over to you, Matt, to do a quick intro.
Yeah, I think Curtis covered it pretty well with myself as well, but just been in the industry for about 13 years now, working first for general contractors, went off into the programming side for scheduling and been with Delta for around 8 years now, primarily working on delay, and have testified a handful of times.
So Matt and I have had the opportunity to work on several mining related claims over the last several years. And so we'll try to speak to some of that as we go through some of these slides. Just like with any project, any construction project, mining claims mining projects, construction projects are susceptible to claims, and they do come up, and often when they do, they're extremely expensive, just given the scale of a lot of these mining construction projects. So we'll walk through discussing what is a construction claim, what are the common causes of construction claims, why do they occur, and then what are the types of claims that are most often seen on construction projects, as well as more specific to the mining industry. And then finishing off with some strategies to avoid the claims and disputes. So when we talk about a construction claim, at the heart, it's a dispute, disagreement between the parties, and they're really seeking to modify the contract, terms of the contract. And most of the time it comes down to money. Even with a time extension request, we think of that as a schedule issue. Ultimately, that boils down to dollars, whether it's the contractor seeking additional compensation for being out on the project longer, or seeking a time extension and therefore relief of liquidated damages because the project is finishing late. At the end of the day, it comes down to the dollar side. As I mentioned earlier, the construction claims, it's starting with the change order, the more formal process that is, parties are unable to resolve that, formulates into a claim, and then if that unresolved ultimately leads into some type of dispute in terms of litigation or arbitration. So common causes of construction claims, for those who have been through a claim in their career, probably seen some of these items, right? So at the heart, there's it's a directed change to the work. The contractor is performing work differently, or is performing different work than what it had estimated or what it had bid. Differing site conditions is a very common one, particularly in the mining industry. Incomplete design or design changes. This often comes up given the rapid pace of engineering for mining projects. Things do come up. Scope is often added as part of this contract, or design is completed while construction is ongoing. Of course, adverse working conditions and changes to the logistics plans, and then incomplete predecessor work by others. And what we mean by this, in some cases on mining projects, we'll see multiple prime contractors on a project where one contractor's work may be dependent on another contractor's work. And where that work is not going as planned, we may see one of the contractors submitting a claim for the impact. Lack of access, and I'll get into some of why that occurs. And then trade stacking and compression relates to often the loss of labor productivity. So these are trades working on top of each other in confined areas. And another issue that we've seen as of late is the effect of tariffs on construction projects. So when we talk about mining projects themselves and what are some of the unique risks there, right? The remote location alone tends to make these mining projects at higher risk, particularly when it comes to workforce and supply chain. The remote location attracting qualified labor to perform the work often becomes an issue, and also retaining that workforce throughout the duration of the project. Supply chain, of course, getting the materials, the equipment to the site is a unique challenge often to these mining projects, especially those in remote locations. Environmental and regulatory constraints are another big deal. There's a lot of projects that we've been involved with where the work was seasonal, was based on limitations of work periods or work locations based on migration of wildlife, rising or water levels for rivers or bodies of water. I mean, there's all kinds of constraints that come into play on these mining projects that are unique, that are not really applicable to projects that we see in urban areas. Of course, another one is the harsh weather conditions with a lot of mining projects or mines being located in areas like the Arctic Circle, which we've worked on a project there, all the way down into South America within the jungle environments. Those harsh weather conditions do make the work more difficult. And then the geotechnical uncertainty, given the remote locations and lack of geotechnical data. And then specialized processes and equipment. The equipment being installed, of course, in these facilities are unique. And the lead time for those, the unique aspects, whether it's the size of the equipment, the duration for fabrication, all make that procurement process and the actual operation, startup of that mining process or equipment becomes another risk to consider. So when we talk about construction claims, we've got really three primary buckets that they fall into. We've got the extension of time, or the delay component. Project was planned to complete on a certain date and is now finishing later. Who caused that? And then how much did it cost? And then the disruption, loss of productivity side really relates to the performance of labor on the project and how that contractor performed in comparison to what it should have been able to achieve. And then the acceleration component, where a project is delayed and the contractor is being asked or is attempting to accelerate to overcome prior delays. So Matt, I'll hand it off to you on talking through some of the types of claims.
Sure. Yeah, so we're going to talk about those various types of claims in more detail here. I'll discuss delay claims, and then I'll throw it back to Corey to talk about loss of productivity, LOP claims. So we typically separate delay claims into two different buckets: prospective and retrospective. Prospective meaning looking forward, and retrospective meaning looking backward. If you're a contractor or an owner on a project, typically you'll be encountering prospective delay analyses because there is some sort of impact occurring on the project, and you want to measure the potential delay caused by that impact. Whereas a retrospective delay, that's typically something after a project is completed, and Corey and I get involved in a lot of matters like that where delay analyses become more complicated and it's more of an after the fact matter. So what separates the two sort of analytically, right? So the prospective occurs typically before the start or definitely before the conclusion of an ongoing delay event. And it's a quantification based on an estimate, right? The delay has not, or the impact causing the delay has not concluded. So it requires some degree of estimation to quantify the delay. In that bucket, it includes assumptions regarding the sequencing of the delay and the timing and the effect. And all of that together, the sequence of the impact and the timing of the impact, we call that modeling the delay. So we are not viewing the delay retrospectively, we are creating a model of what we believe the delay will be. There's really only one reasonable method of calculating this sort of impact, and we'll go through that in a few slides here. As far as the retrospective delay, it occurs after the delay has occurred, or it's done after the delay has occurred. It should be based on what actually happened. That's not always the case, but that's the best practice for performing a retrospective delay analysis. It's often referred to as a forensic delay analysis. No matter what sort of delay analysis methodology is performed, we bucketize it into a forensic delay analysis. And there's many different methods for performing this, a few of which we'll quickly go through. So when we are quantifying delay, we then separate the delay into three different categories. Unexcused, what we call excusable and non-compensable, and then excusable and compensable. And we separate it into these three different categories to determine what amount of delay uh, can be used to extend the contract duration, and then what amount, and that's what we call excusable delay, and then what amount of delay can be used for calculating time-related damages, the cost resulting from the delay, and we call that excusable compensable delay. So the unexcused category is typically due to a contractor responsible delay, something they can't blame on the owner or on the weather or some other sort of issue. And that's, like I said, typically they are not compensated for unexcused delay. That's on the contractor. Excusable non-compensable has two primary causes. One is concurrent delay, so a contractor responsible and an owner responsible delay occurring at the same time is the most common form of concurrent delay. And it's also falls, or weather also falls into excusable non-compensable delay. So if there's a weather event that exceeds what could be expected, then that would be excusable delay. And finally, excusable compensable, typically we would call owner responsible delay. That can be a design change or additional work or unforeseen conditions. Sometimes contracts disallow for that to be compensable delay, and sometimes they do, but that's what we would put into that bucket. So as far as the prospective delay is concerned, what I alluded to, the one method for calculating prospective delay is the TIA, the time impact analysis. It goes by many different names, maybe the schedule impact analysis, the SIA, or the time impact evaluation. Like I said, it's the only real accepted method for forecasting delay. It's commonly required in contracts. Of course, all contracts are different, but most at least spell out some very crude steps for performing a TIA. It's used for estimating delay, right? It's not using a TIA. Theoretically, the delay is not complete, so you won't be able to measure the impact, but you can estimate the impact. And it's useful for proactive management, right? As far as risk is concerned on a project, it's generally better to solve these or to resolve impacts before they are complete rather than they are after the complete. So what are the requirements of a TIA or a time impact analysis? Generally requires what we call a critical path method schedule. That's a schedule that uses activities and logic to tie the activities together. On very simple projects, that might not even be required, but typically with the complexity of mining projects, nearly all of them will have some form of CPM schedule implemented on the project. We need the schedule in place before the event occurred, so we know how the project was going along before this impacted the project. We need some sort of estimate of the duration of the impact. And then crucially, we need to know how the impact is tied into the logic of the project itself. So the de facto body for project controls and delay analysis, claim analysis in the United States is AACE International. The American Association of Cost Engineering is what it used to stand for. And they have several different recommended practices, RPs, that they use to recommend how analyses should be performed. It's not a concrete guideline, but generally provides some good steps. And these are often used by professionals in the US. Outside of the US, there's some other treatises that are used, such as SEL and ASCE, but AACE is the US standard. So the time impact analysis steps spelled out by AACE's recommended practice 52R06, which is their time impact analysis recommended practice. And I'll quickly walk through these, and I'll show you a graphic on the next two slides that better illustrates what we're talking about here. But is to create what we call a fragment, which represents the impact itself. A fragment's an old school term that just really means a sequence of activities in a schedule. You should select the appropriate unimpacted schedule update, which is typically the schedule preceding the beginning of the impact. You should zero out the duration of that fragment to ensure that the insertion of it had no impact on the schedule before it has a duration. You should then insert the durations of the fragment back into the fragment itself. And then we should identify the activity that will be used to measure the impact. Corey and I have worked on mine projects before where there are multiple different milestones on these projects that have maybe some sort of bonus incentive or liquidated damages associated with them. So you might actually be measuring the impact to more than one activity or milestone. You then determine whether you're in calendar days or work days according to the contract, measure the delay to that milestone before and after inserting the fragment, and then you account for any time extensions. And then most importantly, you write your narrative, which hopefully you've been putting together your entire time that tells your story of your TIA. And then the math should theoretically be the easy part of the TIA. So this is just a little 4 activity schedule that we have here with our data date as our vertical line. That's our point in time that we're measuring in our schedule. And then our activity 1 is our completed activity. It's before the data date. And activities 2 through 4 are our forecasted activities. So this is just the schedule without the fragment. And if we go to the next slide, we see the schedule with the fragment. So the impact is inserted at the beginning of the sequence of activities. It's writing the data date. And our measurement of delay is the impact of the fragment on the completion of our sequence of work. So common errors and pitfalls in performing TIAs. We see this all the time. I saw this last week. The contractor not using the proper schedule to incorporate the fragment into. Again, it should be the schedule preceding the start of the impact. Making the fragment too complicated. This is a real keep it simple, stupid situation where you just need typically, hopefully, a few activities to create a fragment if possible. And then, of course, you want to tie that properly into your schedule. Failing to perform the analysis timely, right? You're waiting for better information rather than using your best information that you have and inserting that into the schedule so the parties can start coming to the table and having discussions about what the impact shows. Not addressing concurrent delays. If you're just looking at excusable time, you might not care as much about concurrent delay, but if you're looking for a compensable delay, then concurrent delays are very, very important. And then finally, not listing the assumptions you made in the creation of your TIA in your narrative. Your narrative is so important, and oftentimes fragments will just sort of have not enough information for Corey and I to understand exactly what the analyst or the scheduler was thinking when they put it together. So it's great to document that within your narrative. And then so finally, regarding delay analysis, these are the common types of delay analysis methods spelled out in another recommended practice, 29R03, which we call the forensic schedule analysis, or delay analysis Bible, for lack of a better term. And you'll see that I don't put that graphic in the bottom left corner to walk through it. It's mostly to show that many of these analysis methods all share common names that analysts will sometimes try to use to maybe confuse the situation. But that is to say, there are many different methodologies. Typically, if the information is in place, the gold standard is the contemporaneous schedule analysis, which is using the as submitted schedules, the monthly schedule updates on the project. But if that sort of information isn't available, or if we're on a tight budget, something along those lines, then there's several other different methodologies.
Thanks, Matt. So we talked about the three different kind of categories of claims that we often see: the delay, loss of productivity, and the acceleration. The acceleration is really kind of a mix of both the delay component, showing the delay, and then the acceleration, but then the dollars perspective, or the effect of that acceleration, comes out in the loss of productivity. Now, to be clear, you could have delay and no loss of productivity. You can have loss of productivity and no delay. Commonly, we see them go hand in hand, where there is delay and there is some element of loss of productivity, but often they're treated independent. The loss of productivity component, especially on large industrial projects such as mining, we see that the loss of productivity claims are often the most significant claim, at least in terms of dollar value. And the reason for that is the variability of that labor cost. in a contractor's estimate, their budget, the labor often represents the highest variable cost. Setting aside the procurement of permanent equipment, labor is extremely sensitive and can quickly get out of hand. And given some of those risks that we discussed earlier of mining projects, it becomes a big issue on projects that are suffering from some form of disruption. So, in order for the loss of productivity or increased labor hours beyond what was budgeted or estimated on the project, there's some disruption is occurring. Now, it's not to say that that disruption couldn't be as simple as, well, the contractor may have just underestimated the job. And so they're incurring additional labor hours beyond which they expected. In other cases, there's some change condition. Something is affecting the contractor's ability to perform the work as they had estimated. But before we dive into that, I just want to separate the productivity from the production side. So productivity is the output per measure of the input. So for example, cubic yards of concrete placed per labor hour. That's different than production, which is just great. We had yards of concrete placed, right? So a contractor may say, look, we were to place 100 cubic yards this week, but in order for someone to understand, okay, is that resulting in, or does that signify a loss of productivity? We've got to understand what was the input to that. Meaning, yeah, we poured 100 cubic yards this week, and it only took us 50 labor hours versus we planned 100, right? So understanding that element of the input, which loss of labor productivity claims is the labor component, that's a key issue, and that's how we measure in most cases, any variances and productivity on construction projects. So, what good is our presentation if we don't throw some numbers in here? So, even the productivity measurements themselves and some of the terminology can vary. Some contractors apply what we call a productivity factor. And in that case, that factor is calculated by taking the sum of the actual hours divided by the sum of the earned hours. So in this case, the top formula on the right, 120 actual hours over 90 earned hours, meaning the contractor incurred 120 hours to perform this amount of work, but only earned, or their budget for the work completed was only 90. Productivity factor of 1.33. In this case, of a productivity factor, anything above 1 is bad. You're incurring more hours per unit than planned. And below 1 is good. You're incurring less hours per unit than planned. Performance factor is just the inverse. So instead of up above, actual over earned, the performance factor is dividing earned by the actual hours. In this case, above 1 is good. You've budgeted more hours than you spent. Below 1 is bad. Of course, you spent more than you've earned. It's important when discussing productivity to understand how is this being measured. When a contractor says, look, I'm only achieving a 1.25 productivity factor, okay, puts into context, yep, that's not good. They're spending more labor hours than what they have budgeted. Similarly, a contractor says, look, I got a performance factor of 0.75. They're doing well, right? Or excuse me, they're also doing bad, meaning that 0.75 is below that 1. So that understanding of even how productivity is measured and how we discuss that is important. Loss of productivity claims tend to be extremely complicated, and that's because the factors affecting loss of labor productivity are usually a combination of issues. And And there's lots. We've got some listed here, but I discussed trade stacking earlier, right? You've got more trades working in an area than what was planned. And so you have disruption just from the trades working in between each other, whether it's the electricians working alongside the pipe fitters in a process building versus a staged or sequenced chain of work. So now you have equipment, materials stacked all over, unable to access areas, resulting in higher labor hours per unit and ultimately a loss of productivity. Resequencing of activities, we often see this as it relates to design changes, where a contractor plans to perform work in either a certain area or a certain type of work. They're able to start that. They run into an issue, whether it be a design issue or incomplete information, something's not fitting up right, and now they've got to shift their workforce over to a different area or a different item of work. That becomes disruptive to that labor force. Learning curve is a big issue. We talked about the often on the remote location for mining projects, the ability to not only recruit but also retain labor. There's a project that Matt and I worked on a few years ago up in Wyoming, where the project extended for much longer than what was planned. It extended over for additional winter period, and when the contractor really began to resume work after that winter period, a lot of the experienced craft that was on that project did not come back. And so as new labor is brought on, you've got to put them through the orientation, the hiring process, bring them up to speed on in terms of where the project is, and get them familiar with the project itself. That learning curve has an effect. Similarly, if you're training new workers on new tasks, that learning curve becomes can be a source of disruption. Access constraints, getting to areas, planned areas, but those are either limited in the times available to work, or you have to resequence work because the crews can't get in there for some other reason. Weather impacts are a huge deal. Of course, extreme cold, extreme heat, workers just simply aren't as efficient. We often see this on material supply issues when there's owner provided equipment or the contractor runs into supply chain issues, delays. We often see that with piping or long lead equipment, and then what effect that has on the trades, their ability to keep them busy, keep them productive. We talked about the drawing and design changes. So taking all these factors together, we often see what's referred to as a cumulative impact claim for labor productivity, where the contractor or trade or a subcontractor knows that they overran their estimated labor hours. They know there were a multitude of issues that affected the work, but it becomes extremely difficult to try to separate and identify, okay, you lost so many hours to this issue versus this issue or some other factor. And so often what we see is this claim for the cumulative impact, meaning a lot of these issues were affecting the work, resulting in a loss of labor productivity. Now, where we see the documentation of loss of productivity is what you normally think: the contractor's daily reports, letters, correspondence, and the notices, of course, part of that. The contractor's schedule narrative describing here's what was planned. We didn't get to that. We had to shift crews around. Either resulted in delay or some type of disruption. Of course, change order submissions for increased cost of the work. And more sophisticated contractors will even track or attempt to track their lost labor hours or additional labor hours, standby time, remote time in discrete cost codes. From the owner's perspective, understanding and reviewing those daily reports, what is the contractor submitting on a weekly basis in terms of what work was done, reviewing those schedule narratives gives insight by the owner into what the contractor is observing. So it's important to review the information that's being submitted to understand are there issues affecting the contractor's ability to perform its work? And are those items, those issues put the owner at risk for a potential claim?
I'll chime in and say I often,
Please.
when I'm speaking with contractors, I'll tell them to use their schedule narrative to the advantage because nobody reads it. And then a couple years down the line, you can say, but I told you in the schedule narrative,
Yep.
right? So it's so important to pay attention to that.
It is. Yep. All that documentation. You're absolutely right. Now, when we talk about quantifying loss of productivity, we use a few different methods, but there is a hierarchy to those. Now, I talked about on the prior slide, discrete or direct pricing of loss of productivity. It's a high bar. We rarely, if ever, have seen it done truly correctly, where the contractor has set up a discrete cost code and captured their loss of productivity in any accurate way. Although the gold standard, the more common method that we see, and is really from a forensic standpoint, is what we call the measure mile. And what that boils down to is the comparison of the contractor's performance in an unimpacted area or segment or time of work to the same work, but in that case being impacted. So you have the importance of that measured mile as it proves up that the contractor was able to perform its work as bid, but due to some condition or factor for which they're not responsible, their productivity was reduced. So now you're comparing what the contractor could achieve unimpacted versus what was achieved during the impacted period or type of work. Another close second is the comparative project. We started to see this more often, where a contractor compares its performance on a similar project to the current project where they're experiencing loss of productivity. There are some hurdles to that method, showing that the projects were similar, of course, similar location, similar type of work, similar contracting method, similar time frame. There's a lot of unique considerations when looking at a comparative project analysis when quantifying loss of productivity.
Good afternoon, Midland Research Center.
One of the more common issues that we see, or one of the more common methods that we see, is what we call the modified total cost, where the contractor simply compares what it had bid to what it spent with some adjustments. For example, a contractor may say, look, I overran $1 million on pipe install, but you know what? I know we had our own performance issues, and that, quantify that. That's 200 grand. Owner, you owe me the rest. So there's some adjustment made to that cost overrun to account for the contractor's self-inflicted issues. Going down the line, we see academic and industry factors. The National Association or National Electrical Contractors Association, that's a common one. Mechanical Contractors Association, they each have productivity factors that they use. Those are really for the forward pricing of changed work, so a contractor can assess and accurately price work, but those often get applied in loss of labor productivity claims when the information to be able to do a measured mile or a comparative project are not available. And then on the far right is kind of the bottom of the barrel in terms of the more simplistic method of quantifying loss of productivity, is simply comparing what was planned versus what was spent. There's a series of hurdles that have to be overcome in order to make that claim, at least make it reasonable. And therefore, it's often not viewed as an acceptable method to quantify lost productivity. The primary hurdle is the assumption is all cost overruns are attributable to another party and not the contractor, which is often not the case. Strategies for avoiding claim disputes. I think you got a couple and I got a couple on this one, right? Oh, you're on mute, Matt.
Yep, fire away.
So on the contracting side, the key is really just understanding what does the contract say, and ensuring that whoever you're representing, we're adhering to that. Often that comes in with notification requirements, how issues are documented, and then similarly, from the owner's perspective, making sure to respond and understand this process. The whole idea is, Matt said it earlier on delay claims, the sooner those can be resolved, the better, because unfortunately with claims, the longer they sit, the more tend to get more expensive, kind of like a wine, I guess. Again, the contract, that's the rule book. It defines when the project needs to be done. It'll define often the budgets, the cost of the work, or the bid of, or the contract amount, completion dates, or even durations for specific items. Matt talked earlier about the types of delay. That's where the contract's going to define that, and then what types of delay, when delays occur, how they fall in these buckets, and then more importantly, the change management or claims process. And each of those processes are unique to the contract. Also defines the contractor's obligations in terms of notice, how additional time will be requested, and also how prices will be changed, how changes will be priced. Lump sum versus time and material versus unit price, or some other method. And then also from the owner's obligation, the review and response to claims, change requests, notices, and then how the owner may be liable, or how what they may be responsible for in terms of delay or acceleration. So when we talk about the notification requirements, right, we talked about how you to provide notice. Often we see contracts where there are specific recipients that are required to receive notices, someone who's given authority to respond to those. And then, of course, the recipient. Timing of the notifications is often a very big deal. And the reason that timing is tied to it is so the parties have enough time to react. So, we see anywhere from 24 hours up to 7 days notice, or even more. Understanding those notification requirements and the timing of those is huge. Depending on the state and the laws there, a failure to properly notify can have an effect on the ability to recover from a claim. The content of the notification is huge, right? Saying what delayed the project, when it occurred, why the delay is occurring, being specific to the scope. The whole idea here is to communicate, to tell the other party, here's what's happening, here's how it's affecting us, so they can react reasonably and try to get this issue taken care of or respond accordingly. Other documentations to substantiate the impact, always a good way to supplement or further reinforce what's going on as part of notice. And of course, following that up ultimately with the change order request. One thing to submit notice, but then never say, okay, and here's how much it costs or how much it delayed the project. And that failure to issue notice is an issue that we often see on construction claims, where notice was not provided or was not provided timely. And that becomes often a legal issue, a point of contention amongst the parties. So normal notification process, right? A letter is issued, excuse me, the identification of an impact occurs. Notification is issued, followed up by a change request, or request for equitable adjustment, what we call an REA, and there's either resolution or some type of dispute. Again, some of this is really the documentation side to, as part of the notification, we're capturing the information, what's happening, and documenting it, not just in the notice letter, but of course in the daily information that the contractor generates, whether that be in the daily reports, quality control reports, and often those reports are required for submission to the owner. That timeliness, and then also contemporaneously tracking the costs associated with the change. Ensuring that the change orders is submitted in accordance with the contract. Same thing with notice, making sure it's going to the right parties. making sure the required backup documentation is there in order to substantiate the change. We often deal with issues where a change order is submitted that lacks the documentation or backup to assist the owner in understanding or making a reasonable assessment of the cost or the delay associated with this change, which just drags out the process. Providing the information, the backup is key and often cuts down on the time required to negotiate and resolve changes. As with any any project, often those change orders are not necessarily be able to be resolved as part of the change management process, but the contract will often define then what is the dispute resolution. We see everything from dispute resolution boards to executive committees. And then, of course, those changes enable or the issue isn't able to be resolved as part of that contract will define the dispute process in terms of arbitration or litigation.
So in support of and following notification, what sort of communication can be used between the parties to document changes and impacts to the work? I'll preface this by saying I was being deposed recently where I was the expert for the contractor, had not given notice according to the contract. There was a very specific notice provision in the contract that says you must submit a letter that has this exact heading that says this, this is my notice for X dated X, and they didn't do that. And I attempted to argue that, well, they had given notice via some RFIs and things like that, but still, it was pretty hard to argue against the very clear contract language. Regardless, in support of changes and following notice and potentially preceding notice, there's communication back and forth between the parties, right? But from the owner, when the owner is directing changes to the work, that can mean an RFP, it can mean a change directive, it can mean a design change, or often RFIs. And then when the contractor or a subcontractor is documenting impacts, there's a variety of mediums for that, right? Daily reports, meetings, or observations by field management, often in emails or also in meetings. So as far as documenting impacts, this has gotten a lot easier in the last 5 or so years with Procore becoming so prevalent in other competing systems. But over documentation is preferred, right? Because years down the line, when Corey and I get hired for these sorts of matters, everyone on the job is gone, right? They're 4 project managers deep. The project knowledge is lost. And so the more contemporaneous documentation we have of impacts, the better. One of the best ones is daily reports. And like I said, with Procore now, we can export that to Excel, sort it out, takes 10 minutes to extract the information we're looking for. But general sorts of information that should be recorded on a daily basis, especially if there is an impact, is the work performed, who's working on the work, the quantities performed that are associated with that scope of work, what the weather is, any sort of conversations that are occurring. This will make everyone's lives easier years down the road, even though at the time the project team might feel that this is just some sort of bureaucratic nightmare. And then so finally, it's great on projects to keep an issue log. Corey and I were discussing before this, and oftentimes on projects, it seems that RFIs are being used as issue logs as a sort of informal ad hoc issue log, right? Where every time that there's a potential issue, the contractor is submitting an RFI, and then the back and forth on the RFI is basically the documentation of the impact. We implore you to use an issue log in lieu of RFIs. The RFIs might be associated with the issue log, but the issue log can also record more information and track everything and record cost estimates and more information regarding each of these issues. And for example, on this issue log, there's notes that are recorded that might not be recorded in an RFI for each of these line items. So our conclusion, I'll read through the first one just because it's just a distilled formal version of a construction claim. It's a formal request made by a party in a construction contract seeking time, cost, or another adjustment to the contract terms due to the impact of the project. As Corey discussed, mine projects have specific causes of claims due to their remote and/or harsh conditions. There's a lot of overlap with standard construction projects, as you may call them, but they also have their own unique aspects. To avoid claims, understand the contract, comply with notice, document impacts, document, and manage all of those impacts using some sort of formal record keeping or a log. And that's it.
I do have a question in the chat from Curtis here. What improvements in project management office functions and sophistications has Delta observed in the past decade?
Matt mentioned Procore, the automation system where you can dive into one service, and it's a lot of the notice letters, the correspondence, the RFI schedules, all that information is in one area, and that becomes very, very helpful. At the same time, while technology has helped us in that area, it can hurt too. We see that in the improper scheduling. It's easy to tie some activities together in a schedule. But is it right? Does it make sense? Has it been reviewed by the people responsible for performing the work? I don't know, Matt, what other technology things have you seen to help improve what we deal with?
I mean, Procore is the big one. It seemed like up until 5 years ago, I was going through daily reports that were written in
Handwritten,
Procore. Yeah. So that's been
that does
huge.
help.
Outside of that, it's not like there's been like a marked improvement in project controls, honestly, that I've noticed. It does seem like, there's some various schedule analysis tools that are pretty user-friendly that we see more projects using that,
Yep.
tools like Acumen Fuse that were typically just used by forensics folks.
And that's software to measure the quality of the schedules and
Yep.
give the schedule team, project management team insight into how they're performing as planned, but also are there issues with the schedule itself.
Yeah, so it seems like knowledge of that software is becoming a little more commonplace. But of course, even if a schedule is high quality, it doesn't necessarily mean that it reflects what's going on the project.
Sure. Yeah.
Great. We have another question here from Brett. Can you talk about the critical path method schedule concepts and how that relates to delay, impact, and trade compression issues?
Sure. Matt, I'll let you.
Yeah, so first to start off with the critical path method. So that's been the industry standard since the Polaris missile program in the 1950s, right? When this was all developed, where in its very essence, you can do it by hand. Whenever I teach critical path method scheduling, I make them do it by hand, where it's a sequence of activities with durations, and it's all tied together with relationships. That's very easy to calculate by hand when you have 10 activities, but when you have 10,000 activities, you have to rely on the computer. Theoretically, you could do it yourself, but it's not preferred. We then use that network of activities in the critical path to determine what is, or in that network to determine what is our critical path, so our longest path, our longest continuous chain of activities through a given milestone, whether that's substantial completion or some sort of interim completion milestone. I believe your question was on compression or trade stacking. Usually that's fairly evident in a schedule, in a critical path method schedule, because if the schedule is created with enough granularity, you can see the activities, what was previously a chain of activities compressing into overlapping on top of each other.
Yep.
And if a schedule is resource loaded, you could then look at the resources, such as crews assigned to those activities, and see that they're overlapping and compared to the original baseline.
Yeah, we see a level of sophistication in the scheduling that often occurs now, really, particularly by trade contractors who are they're wanting to understand what's their requirement for labor on a specific project. And so what we'll be able to do is analyze, what's the amount of labor in a specific area of the project or during a given or specific period, and to see, okay, is that level of labor higher than what was planned or suitable for where they're working. And so there's a lot of information that we can get from the schedules that help us understand if there is in fact crew stacking going on, and then to what extent.
So yeah, it's really garbage in, garbage out, because many schedules you'll find of the complexity required to construct a mine are typically resource loaded. So they'll have electrical crews, civil crews, steel crews assigned to complete the activities in the schedule. But you'll often find that those resources aren't maintained as the project proceeds. So the resources and the crew begin to not reflect reality. So the schedule can be used to measure compression, but I would be very weary of what the schedule is showing as opposed to what is actually occurring.
Yeah.
Okay. Brett had a follow-up to that, which is, can you talk about contemporaneous schedule update auditing, claim digger, needed with
Yeah.
each update and why?
Yeah, so I do a lot of those for ongoing projects. So Claim Digger is software just like Steel Ray or like Acumen Fuse, where it's giving the types of relationships used in a schedule, or if there are missing relationships in the schedule. So when I'm talking about relationships, it's how the activities in a schedule are tied together, whether it's a finish to start relationship or a start to start and various other quality aspects of a schedule that I won't bore y'all with. But that does fall into that Acumen Fuse bucket where it's the same type of software. Claim Digger is fairly inexpensive, is my understanding. So it's great to buy a copy of it and use it on an ongoing project at the project site.
So we'll use that software to compare one update to another to
Mhm.
figure out what is being changed. Matt talked about it or showed briefly what we call the half-step method of analysis, and that separates or bifurcates the effect of progress, actual starts, actual finishes, are we completing what we have planned versus revisions. Often what we see in schedules is an attempt to maintain a start date or a completion date, sorry. And that's achieved often not through the as planned progression of work, but through revisions to the schedule. Cutting logic ties, the sequence of activities, that stacking that Brett asked about earlier. And so what Matt talked about the stair step, nice logical flow. And then if you look towards the end of the project, upfront delays, they try to maintain the completion date. And so that's where that compression comes in on the back end. Instead of being a finish to start where the earthwork finishes before the structural work can start, now you start to see an overlap. And so that now they're being performed concurrently. So that Claim Digger software allows for a comparison of schedules to see what changes are being made.
Yeah. Those are changes that are really hard to see just by looking at the
Yeah.
schedule, just a PDF printout of the schedule, something like that, but fairly simple to determine if you have software like that.
Yep.
Okay, Michael Boyce had a kind of follow-up question on that line. Have you seen Acumen Fuse used as the basis for a claim for a poor schedule?
Well, if it's a claim for a poor schedule, kind of two different things, right? It's usually, when you're developing your baseline schedule, there's some back and forth on schedule logic, things like that. Usually contracts will have some sort of requirement. We have used Acumen Fuse to demonstrate that a schedule is of such poor quality that it cannot be used for a claim analysis just because it's not reflecting reality. So if it had all sorts of errors in logic, missing logic, things like that, that could be a part of your argument of arguing that.
Yeah, I've opined or provided opinions on the standard of care provided by contractors in terms of the quality of schedules, and we'll use software like Acumen Fuse as a component of that assessment of the standard of care by the contractor.
Yeah, there's something called the DCMA 14 point, which
Yep.
is good and bad, but somehow it's pretty commonplace at this point, which has some general guidelines on schedule quality.
Yep.
Okay. Curtis had another question for who owns Procore for a project, the owner, contractor, or joint central app?
I've seen both. Yeah. Sometimes owners, I've seen it where, especially in municipalities where they have multiple projects ongoing, the contractor will go into their software and use Procore or something like it. Conversely, a lot of large contractors have their own Procore licenses, and they have those set up throughout different projects. Often it's larger projects where large contractors are involved. They want to maintain that because it allows them then to take information from across a series of projects and view performance on more of a program basis.
Great. Another question here from Brett. Can you please comment on the value of resource loading schedule for providing early indications of overconsumption of resources that may indicate the development of a claim issue?
Yeah, it's if it's done properly, it's hugely useful.
Yeah, it
The
is. Yeah.
schedule is built well, and if the resources are assigned properly. So, for example, if an activity is going to have 2 crews on it, then I would hope that the resources assigned to that activity is actually 2 crews, right?
Yeah.
Or the resource size if they're going to that level of detail.
Yep.
And
And
if it's to address a claim, once you've assigned your resources to your activities in, for example, Primavera P6, which is the standard scheduling application, you could then use that to build curves of your resources to see if they're exceeding some sort of availability threshold, for example.
Yeah. Then comparing that plan to the actual, whether those actuals are maintained in the scheduling software or pulling that information from the job cost report, it makes it very, if done correctly, like Matt said, makes it very easy to do a comparison of any increase in labor force or stacking of different trades.
Great. Michael just says, thanks for the great discussion. And James, thanks, good information and presentation. Are there any other questions from anyone before we wrap up? Great. Anything else, Corey or Matthew, you guys would like to add before I end up?
No,
thank you for
great
your time.
questions. Thank you so much for your time. I appreciate everybody attending.
Perfect.
Thank you very much to Brett Gross for arranging today's webinar.
Many thanks to Corey and Matthew for their excellent presentation, and thank you for all who attended the webinar. All of our webinars are uploaded to YouTube and can be accessed through the MMSA.net website. The video of this webinar should be on the website within a week. We will post on our LinkedIn pages when the video and slides are posted on our website. Our next webinar will be in January by Alistair Horn on AI use for exploration. We will post the PR and date for this in the coming weeks on our website, LinkedIn, and Eventbrite. The MMSA webinars are supported by the MMSA Jackling Foundation. Again, if you're interested in becoming an MMSA member, please be sure to check out our website for information on the application process. The webinar is now ended. Thank you.